Hello and welcome back to the Biostasis Technologies podcast. I'm your host, Max Moore, and today's guest is Jessica Radley from Nectome, a fairly new entrant to the biostasis field, which seems to be rapidly growing these days. So welcome, Jessica.
Thank you. It's good to be here.
Yeah. So traditionally, of course, cryonics has been the dominant mode for biostasis, and then chemical preservation in the last 10 years or so has been increasingly more and more attention paid to that, although the idea is not new, as you're familiar with. Eric Drexler wrote about chemical
Mhm.
preservation, something very similar to actually what people are offering today back in 1986. So it's been around for quite a while, but only now are organizations like yours and Spark Spring Preservation starting to do this. So would you tell us a little bit about the background of Nectome, what it offers, how it differs from other biostasis organizations?
Yeah, sure. Aurelia is really the core developer of the protocol here. And back in 2015, she was setting out trying to solve the Brain Preservation Foundation's prize for being able to vitrify brains and then rewarm them and be able to look at the nanoscale to see if you can still see the synapses and the connections between the neurons. And this had never been done successfully in a whole brain before in any sort of cryonics or vitrification context. And so the Brain Preservation Foundation Prize was the first time that any organization in the world had ever preserved a brain at vitrification temperatures and rewarmed it at a level where you could see the synapses still intact and traceable throughout the brain. And so that was the genesis of both our protocol and the company and the offering. And in some ways, the first introduction of chemopreservation into the space of cryonics in any real sense of it, where it's like, here's something you could actually do.
Yeah. So for those who are not very familiar with the field, how does what you're doing differ from the traditional approaches?
Yeah, so I mean, it started out basically with being people cooling down individual cells, and you can freeze a sperm cell and an egg cell, and then rewarm them later, and they're actually viable. You can then implant them. This has been possible for quite a while, and people were like, "That's amazing. We should do more of that, right? What if you could do whole humans? Imagine the possibilities for space travel, right?" And then so that kind of spawned a whole field, and people started trying to do this in organs and whole organisms, and it turns out it doesn't work very well if you just try to cool something down larger than a certain size. You can freeze a nematode, but you can't freeze like a rabbit, for example, or anything mammalian sized. And so then people started adding cryoprotectant to try and prevent ice crystal damage, and that more or less is the process that traditional cryonics does today. And so the chemopreservation is a whole other approach at this, where instead of trying to get an animal back or a person by straight cooling and rewarming, we sort of give up on that idea of that being possible in the near term, because it introduces a lot of damage, and sort of doesn't work in the simple revival scenario where you simply rewarm. And so given that, let's try to preserve the structure and the cellular relationships as well as possible. And so the chemopreservation essentially uses aldehyde fixatives, commonly used in embalming, like formaldehyde is one. We tend to use glutaraldehyde. And these are very effective at preserving brain structure, but they're obviously non-reversible in a modern context. And then we will introduce cryoprotectant afterwards to allow for vitrification the same way that you might with the traditional cryo approach.
Yeah, so you said it's not reversible, at least by regular standards.
Mhm.
So is the idea? So are you sort of pro uploading here, or are you sort of neutral? So some people see chemical preservation as incompatible with revival. I'm not sure that's necessarily the case if we have advanced technology, but is
Yeah.
is basically the idea of Nectome that you want to upload people rather than come back biologically, or are you open to both options? What do you think is the case?
Yeah, so our historical kind of conversation around this has really tended to be something along the lines of chemopreservation is something you would do for uploading, and cryopreservation is something you would do for direct biological revival. And this isn't actually true. In actual fact, it's not possible to do a direct revival of anything in the current, given any protocol at all. So in every case that really exists in the actual world that we're in right now, you need to be able to do some kind of information analysis. There's going to be some amount of repair of damage and reconstruction necessary. And that will require advanced technology no matter what you're doing. And so the question really is, have you preserved the relevant structures sufficiently that you can know what was even in there? Or was there a lot of damage done in a way that obscures some or even very large parts of the brain? So given that context, it is, I think, more reasonable to expect that if a mechanism for revival could work in the traditional cryonics case, it very likely can also work in the fixation case because they require similar levels of advanced nanotechnology, essentially, to be able to repair damaged tissues.
Mm-hmm. And the only way that would not be the case is if we get so good at doing cryopreservation, under ideal conditions, that we wouldn't need such an advanced level of repair. But otherwise, yeah, I pretty much agree with you. So this old idea, I think, 10 years ago or so, it seemed like it was biological repair people versus uploading people, and cryo versus chemo. But that doesn't really seem to be the case much anymore, as you say. I think you can do both. Cryo can lead to uploading or to biological revival, and vice versa. So I don't think that's really the fault line anymore. I think it's just historically the people first interested in chemopreservation seem to be more interested in uploading. That was kind of the main goal. So people sort of made that association. It wasn't really a correct one, logically speaking.
Uh-huh. I think it's probably true that it feels more intuitive that you might consider something like uploading from the chemopreservation side of it. Because if your story is something of a biological viability perspective, it's like, well, obviously a chemopreserved person is not biologically viable. But that's also true of a cryopreserved person. And so they're really the same context.
Yeah. By the way, I should take a step back before we got to Nectome. I should probably advise this first, but we can do that. I'm always curious. This is a pretty unusual thing to do, right? Still, I mean, you and I can talk about this stuff, like a normal idea because it's something we've both been into for a while. But it really is a very unusual thing. So I'm always curious.
Yep.
How do people get into these ideas? What was your first exposure to biostasis in general or life extension? Where did that come from?
I think that I have always believed that technology could change the way things are and eventually kind of radically alter the way that we live. And so that was kind of a baseline experience for me of just, if you look at history, it's sort of obvious that we can do things now that we didn't have the ability to do before. I was really interested in space travel and like airplanes and just how things worked in general growing up. And so there was a lot of curiosity there and a general sense that we can do lots of interesting things in the future. But I don't know if I was ever really particularly interested in cryonics or life extension exactly, mostly because it seemed so far away and kind of far-fetched relative to where we were that I didn't know how useful it was or how much it mattered. But it must have been 2016, I ran across a talk Aurelia was giving where she had just recently developed the protocol for ASC and was able to preserve whole mammalian brains at this extreme level of quality. And I'd never actually seen an electron micrograph of a brain before, but she walked through the different parts of it, and I was just totally blown away by this. It's really amazing. You can see vesicles containing neurotransmitter inside of the synapses. Like you can see the mitochondria, you can see the DNA. It's amazing. I didn't think that was even remotely possible. And it seemed pretty obvious to me after, relatively short exposure to this, that if you could preserve the whole structure of the brain this way, that you definitely have preserved that person. And everything I've learned since then has confirmed this. Many conversations with neuroscientists, memory researchers, all the things that I've read. It's really hard to imagine a world where the things that we know about how the brain works are true and also preserving structure is insufficient.
Mm-hmm. So it sounds like it wasn't that you were, first of all, driven by life extension and then sort of looked for an effective means of it. It's more like kind of interested in technological advances and you found this really cool thing and got into it that way more.
Yeah, I want us as a society, as a culture, as all of humanity to sort of push the technological frontier forward and become more capable as a species. I think this is something that we should do, that's important for us to continue doing. It improves our lives and it improves our ability to interact with and care for the natural world. And I think this is sort of an imperative that we have. But the preservation angle is a little bit more of a humanitarian thing. It's like, well, if we can do this, and it's kind of on that edge already, we really ought to, because then, as many people as possible are going to be able to enjoy the fruits of our labors in the future.
So I take it then that, like many of us, you're overall an optimist about the future. You think that the future is full of possibility, that we're not doomed, because there isn't much point in doing these things if we think we're going to come back to a world that's run by terminators or devastated, or desert-like world. So presumably you think that generally, as you said, we do things today that we can never do in the past. So you see the future as being full of possibility and potential, a place worth coming back to, presumably.
This is an interesting question. I think that absolutely there are potential futures that are going to be amazing. And I think there are potential futures that are terrible. And it is up to us now to build the futures that are amazing. And I don't think that's something that happens by default. I think we have kind of the responsibility to create for ourselves the kind of future we would like to go to.
Yes, well said. It bothers me that there's a very broad transhumanist community and all kinds of different views within that. But there are some people who, if you ask them this, that they will say, "No, I'm not that way." But there are some people who sort of have the implication that progress is automatic, that it's inevitable, that this will happen
Mm-hmm.
regardless. And I've always disagreed with that. I think, as you say, we have to make an effort to make the world better. It doesn't just happen.
Yep.
I think it likely will turn out well, but there are all kinds of bad things that can happen. I can see all kinds of ways the world could go go wrong. There's no guarantee
Mm-hmm.
civilizations do decline. So yeah, I think it's very important that uh, when we talk about optimism, I like to call it dynamic optimism. Basically, we don't just sit back and feel good about the future; we create that future. So so I think that's it.
Yeah, absolutely.
Yeah. Um, has having another well-funded company actually quite nearby, right? Sparks Brain Preservation. Has that changed your own business development strategies for Connectome?
You know, this is interesting too. Like, I don't really see us in competition with Sparks. Like, in some sense, we're doing a radically different protocol that both happen to share the commonality of chemopreservation. Ours is whole body. It is non-emergency. It is exclusively perfusion. Theirs is essentially just the brain and involves some perfusion and immersion, and it's an emergency protocol by definition.
Okay.
And so, in some sense, it would actually potentially make sense to sign up for both Nectome and Sparks, because in the event that an emergency situation happens to you where Nectome can't do something about it, Sparks might be a reasonable option.
Mhm.
But this could also be true of another organization as well.
Yeah, I think people shouldn't worry too much about competition. There's been some of that alcohol versus CI kind of stuff, and but it's kind of absurd when we have just a few thousand people on the planet signed up for any kind of biostasis, and there are
Right.
billions of people out there still. So it's hardly a tapped market. On the other hand, it's possible there are only a few thousand people who are willing to think about these things. But I think we have to do a better job at getting the
Yeah,
ideas out there.
I think that our real competition is just not knowing about what we're doing. The people who have just never heard of any of this, and that's the vast majority of people, I think. I don't think that it is the case that everyone's heard about it and only this many people will accept it.
No, I think that's right. It's hard for me to believe that sometimes because I've done, just personally, I've done hundreds of interviews and media and TV and newspapers, and I think surely everybody's heard about this by now. But no, I talk to people and say, "What is that? What are you talking about?" So no,
Yep.
even if they have heard about it, it's probably something from a science fiction movie or something they read that's very inaccurate. So no, we have a lot of work still to get the word out there. That's just the number one thing, right? Then you have to actually get
Uh-huh.
people to think about it seriously rather than immediately having this kind of intellectual immune response where they don't want to think about it because it disturbs them, because it's
Yep.
upsetting some fundamentals. So it's a difficult one. Um, okay. So, as you mentioned, you differ a bit from Sparks, who focus really on, as is in the name, Sparks brain preservation, and you're offering whole body chemopreservation. Was that the
Mhm.
original plan, or is that something that you kind of decided a bit later on?
The focus of our discussions or our conversations with people in the world have always been about brains, because in some sense, the brain is the hardest part of the body to preserve at the level of detail you need. And a lot of other organs and tissues are relatively simple to preserve by comparison. And so if you can preserve the brain, that's at least a minimum bar, right? But I think it's always been the case that if you can preserve more of the body in with a high degree of quality, that you should. I mean, for example, if you look at the spinal column, there's white and gray matter there, and Aurelia says something like 100 times more total volume than a mouse brain. So
Wow.
there could be an awful lot in the rest of the body that we're just not paying much attention to in the way we talk about it, or you know the general conception of things. And why throw it away if you don't have to?
Yeah, well, that's really a matter of, I think, well, there's some practical factors, but obviously one big factor is cost. At least
Mm-hmm.
in traditional cryopreservation, storage costs can be significant because we're talking about storing people for decades. We don't know how long, maybe a century. So you have to
Yeah.
be able to afford that. And obviously, one head, one brain takes up about 10% of the space of a whole body. So how does that affect your cost structure? What is it? How much do you allocate for storage costs, and how much difference
Yeah.
does a whole body make versus I would say just a brain?
Well, so the cost structure is a little bit different for chemopreservation. This is partly to do with storage temperatures, but like liquid nitrogen is a thing that we could potentially do. But it was never something we actually want to do, because if you go all the way to liquid nitrogen temperature, you get cracking, and that can be pretty disruptive to the structure of the brain. I've heard people make the argument that you could just straightforwardly like map the shearing from one to the other, but I don't buy it. I think you should prevent the damage if you know that it's going to happen. And so we've always been either at intermediate temperature or warmer than the ice transition temperature, one of the two. Um, Intermediate temperature being below vitrification, but not so low that you're at liquid nitrogen. So the original ASA protocol was at that intermediate temperature, and then our more recent evidence shows that it is likely that you can hold on to a chemopreserved person for quite some time at room temperature even. And so low temperature, but still liquid state is where we're aiming. So we want to go to, because there's cryoprotectant that's below 0 degrees Celsius, but it needs to be above that freezing temperature for the cryopreserved tissue. And so we're looking at minus 20-ish, maybe minus 30, somewhere in that range.
So mechanical
And
freezes rather than liquid nitrogen.
yeah, yeah. And so that opens up an entirely different process. It fits into a standard cold chain. You could have a walk-in freezer. There are lots of different ways you could build an efficient cooling system around this that are more off the shelf. And one of the more exciting aspects of this is that you're also potentially available for permafrost. So that's something that, as we scale, assuming people show enough interest in this that we start having this problem. But as we scale, it starts to make sense to have a dedicated site somewhere that is going to be cold year round, and that is just automatically, by nature of the geothermal behavior, just going to keep them at the right temperature.
Hmm. So there'll be a Nectome storage facility in the Antarctic at some point.
That'd be pretty great. Yeah.
Yeah. Okay. So you mentioned long-term preservation at room temperature or close to room temperature. What evidence actually do you have that that's something that is going to be good enough for a period of decades?
Well, so this is unpublished work, so I can't really like cite it for you in a way that you'll find compelling. But we've done internally some accelerated aging studies, including putting preserved tissue in like 60 degrees Celsius temperatures for weeks and months. And with the Arrhenius equation sort of extrapolation, you get quite a few years out of that at room temperature.
I'm always a little bit suspicious of those kind of tests, though. It's kind of like
Oh, sure, sure.
like testing for toxicity. So let's give someone 1,000 times the usual level of toxicity and see how they do, and actually end up with pretty bad results usually. But
Well, so
yeah.
so our actual plan is to have donor tissue alongside the actual, preserved people that we are trying to keep safe,
Mm.
and then we can do biopsies on the donor tissue over time and see how it's doing. So whatever storage temperature we're at, we'll know if things start to degrade and to what degree, and be able to respond accordingly. If it becomes necessary to vitrify, we still have that option. We will still be using enough cryoprotectant that it's possible to vitrify.
Okay, so what level of concentration, I mean, molar are you looking at?
Oh, I'd have to look this one up. Unfortunately, this is not quite my domain, but it is sufficient for vitrification temperatures at least. I think it's higher than what is used in the traditional cryo context because you can actually get higher concentrations of cryoprotectant into the um, chemopreserved tissues without causing as much damage to them.
Could you talk a little bit about the actual procedure itself, like from start to
Mhm.
finish? And also, you mentioned it's a non-emergency procedure, so maybe
Yeah.
elaborate on that a little bit too.
All right. So the key thing here is that in our research, we've seen a very clear correlation between a short time window after death and a high quality preservation. So if you wait too long, essentially the vasculature constricts or something happens that causes what's known as the no reflow phenomenon. And this means that you can't perfuse the brain adequately after a certain amount of time. And we first discovered this when we were doing human postmortem donations, a couple of hours postmortem. If you do those and you look at the brain with the electron micrograph, you find whole regions of the brain have been destroyed because they just simply cannot perfuse after that much time. And so if you compare that to the results we got in the Brain Preservation Prize on small and large mammals in the research context, it's nowhere near as good. And so it's like, well, that's an issue. We need to figure out how long we actually have. So we went back to rat experiments and we started doing progressively longer intervals to compare. And it was pretty clear that after about 15 minutes, you start having a randomly increasing amount of damage. And by 20 minutes, it was pretty universally whole regions of the brain would not perfuse. And
After
within
20
12
minutes?
minutes,
Really?
yeah,
Wow.
and within 12 minutes, you're pretty much guaranteed to be safe. And this is with blood thinners. Like this is after allowing some attempt to lengthen that window. Because if you don't lengthen that window, it's between 0 and 3 minutes.
How do you account for cryonics organizations getting pretty good perfusion after hours, as shown by CT
Well,
scans?
I mean, it depends on what you mean by pretty good perfusion. Uh, and I guess you'd have to, if you can show me a CT scan where the whole brain gets perfused hours afterwards, I'd be pretty impressed.
Yeah, well, I think there are some pretty good ones out there. We'd have to. It's something we can't really tackle right now, but I think there are some pretty good ones. Um, Although it's interesting that not the most well perfused parts of the brain, interestingly, seem to be the things that I would be most concerned about. The cortex and so on. Some of the areas that don't often get perfused so well are the parts that might actually be more replaceable. Might sound weird to talk about replacing parts of the brain, but it is a complex machine, and not all parts of it are necessarily personal survival critical.
Mhm.
Um, but yeah, look at that. That's something we
Yeah.
can follow up on maybe at
So
some
there
point.
is some variation between individuals, even
Yeah, oh, yeah.
of the same species, where some of them won't perfuse nearly as well as others. It might depend on how they died. It might depend on some aspect of their genetics or the actual configuration of their neuroanatomy. But it's if you want a reliable, high quality perfusion, it is somewhat undeniably connected to the time frame after death.
Well, you definitely want to minimize it
Yeah.
whenever you can.
Mhm.
The problem is it's not always possible to do that. So
Right.
obviously, you do non-emergency situations. What happens uh, if you don't have those kind of ideal conditions? What if you have a patient, say, dying on the way to your facility? What do you do in that case? Do you just do the best you can anyway, or is there a cutoff?
Well, so we're dedicated to having extremely high quality preservation. We want to have the best quality that you can possibly create in a reliable, repeatable context. And we don't yet have a protocol that works under those circumstances. The best you're going to get is essentially what other people have already done. This is where I would refer to another cryonics org or another biostasis company to take over for the emergency context. We may eventually develop an emergency protocol, but at the moment, we don't have any candidates that are sufficient and shown to be high enough quality that they're essentially meet our minimum bar.
It's the very difficult part of biostasis is the standby, getting to people quickly, all the logistics. I think that's actually the hardest part to get right and to do well consistently.
Mhm.
So I think you kind of reduce your market perhaps by restricting it like that, but you also make it easier on yourself too. You get more better quality. But as you say, that leaves other organizations with different protocols if that works better for people. So again, it's kind of not really a competition here. It's a matter of choice. And actually, I also kind of agree with what you're saying about having arrangements with more than one organization. I know some people already do that with cryonics organizations that may have Alcor and CI as a backup, but there's no reason why you couldn't have more than one. Well, I guess there are some reasons. There are financial complications because you have to fund it, and so the organization obviously has to know which one is getting the funding. Um, yeah, so we talked a bit about sort of in the abstract about cost. What actually are the costs for somebody to take advantage of your procedure?
Yeah, so right now, if you were wanting to be preserved, it's about $250,000 essentially to do this whole process. This does not include travel or medical expenses. It could be paid with life insurance, but you would have to have had that set up already, and you'd need some way to transfer the insurance to Nectome. And so there's a whole process there, but that is in principle possible. You also have to meet the criteria for medical aid in dying, because as a non-emergency procedure, this is essentially the only way to get that short time window, which means that you've got to be diagnosed terminal. That's 6 months or less, and you've got to be willing and able to come to where we are in order to actually do the preservation.
So that's a real challenge, I think, because having ran alcohol for a number of years, I saw a lot of cases, and we always prefer for people to come to Arizona, to come to alcohol because obviously that minimizes delays. You don't have to worry about missing flights and all that kind of the skimming delay and so on. But that's really hard to do for most people. I often refer to the Fred Chamberlain case, since he was the co-founder of Alcor. He was in Florida, and it didn't look like we were going to be able to get him to Arizona very easily. But they changed his medications. They kind of perked up a bit, managed to get him on the plane, and got him to Arizona. The same thing with Hal Finney, who had to be moved from California. But those are very much the exception. There's been a few people who've relocated when they don't have much time left, but it's really very hard to do. So that could be a major challenge, I think, for what you're offering. And one thing, maybe you're considering this already, but you might want to have people on staff who are actually good at helping deal with that kind of issue, like arranging nursing
Mm-hmm.
homes, arranging the medical aid in dying, because people come from states that aren't used to doing that. People who are good at dealing with families, because you also have to deal with family dynamics, of course. People who don't really want their
Right,
loved ones
right.
to move out of state away from home at the last minute. So, do you have any thoughts on that and or plans for that?
You know, these are definitely logistical problems. They are different logistical problems from trying to go to wherever someone happens to die soon enough anywhere in the states or in the world. Um, I think they're easier logistical problems than the ones where you have to be on standby and able to actually get there in time, considering how short the time frame actually is. And so we're really kind of constrained by this one in that sense. Yeah, we'll do whatever we can to make the process smoother and easier, but it certainly is going to be fairly complicated for people to do. This is something that gets easier with scale. If we are just a couple of people a year, it's probably as hard as it gets. But if this is something eventually that you can have in every major city, and it gets a lot easier, right? If you happen to be in the local area near where a preservation center is, then it's not that big of a move for you. But if you're on the other side of the continent from it, then it's much harder.
Yeah. Yeah, so which is harder? It's different kinds of difficulty. I think the
Hmm.
issue of getting to people, getting a team to people, maybe across the country, is a difficult logistic issue. But it's a different kind of difficulty than dealing with families who may be hostile to the idea or confused or not wanting to let go. That's a whole different thing. And I
Hmm.
think a lot of the people involved in biostasis tend to have a technical background and may not always necessarily appreciate some of those sort of softer psychological family factors. Those can be really difficult and definitely worth paying attention to because that can that can lead to lawsuits. It can lead to all kinds of problems. So on, not getting preserved and so on. So it's a different kind of difficulty, but I think equally important. And perhaps, as this idea spreads, as hopefully it will spread, it's been very slow for the last 50 years, but hopefully this will spread more. That should hopefully mean that more families are familiar with this process, and hopefully that won't be such a big problem in the future.
Mhm. I mean, a lot of the things you mentioned don't go away just because you're doing standby in their state. You
No,
still
no.
have families who don't understand and who are not interested or don't want this to be happening. And you still have lawsuits, right? This it's just hard to run a cryonics company in the end.
Yeah. Which actually, one thing that makes it maybe more workable for the way standard organizations have done this before is they have memberships, right? People join as members, and they often are members for many years, perhaps decades before, and hopefully, not always the case, but hopefully discuss this with their family, so they, it's not a big surprise. That doesn't always happen, unfortunately.
Yeah.
Now, my understanding is Nectome doesn't have members. Is that right? How do you, if that's the case, how do you track people who want your services, and how do you settle the costs when the time is come?
It's always been a little unclear to me what the value of the membership actually is, because there's still costs of doing the preservation on the far side of it that you're paying with insurance. Uh, we're essentially just dispensing with that whole membership idea, and you're essentially paying uh, for this to happen, the same way that you might for surgery or something like that. Except in our context, it's of course kind of a experimental research program where they need to donate their body and essentially wait for things to be developed and for a potential future outcome, right? And so it's sort of in a different class from a surgery in terms of like the people participating. I'm not sure that the term patient is really appropriate here, given that. But certainly some kind of research participation fee essentially is what we're doing here,
Mhm.
and it covers the costs of doing a preservation, of the storage, and of the eventual revival if that becomes possible, and the work that we would do in the interim to try and develop that kind of revival or make it practically operable. But this is it's going to be there's an upfront cost for everyone regardless of membership right now.
So usually your membership fees, the purpose of those really is to keep the organization functioning, right? So operations
Uh-huh.
can work, so you can have the standby team, you can have, the whole organization can be run. So if you're not having membership fees, you have to have one or two other things, right? You either have to have a good infusion of capital to begin with to allow you to keep functioning until you have enough patients, or you have to have enough people coming in that you can pay for, the upkeep of the organization. And until you have a fairly large number of people, that's going to be pretty tough. So how is that working? Do you have funding that's going to keep you going for X number of years until you have sufficient income from doing cases, or how does that work?
I mean, so Nectome is a for-profit venture-backed company, which is a very different model from what most everyone else is doing. And so that basically means that we have access to a source of funding to run the company in this way, where we don't really we don't rely on like a crowdfunding kind of model, which is essentially what you're describing the membership as, where the small community of people who are interested in this over time are sort of putting in a little bit each to keep it running. Uh, you know, this whole industry kind of came up as a grassroots thing, right? There were a few people very
Yeah.
excited about this who found each other, and they started just doing it. Getting ice at the convenience store and doing what they could do. And I think Nectome is kind of in this sort of middle ground where it's trying to go into more of a this is like an industry, and it's like a field with people, ideally many more people than have heard of it before coming in. We're trying to scale it in a larger way than has been done before. And of course, if that doesn't happen, we're kind of back in that more challenging situation of a few people a year is hard to run a whole company, right? But if we can scale it, then it's the sort of thing where it can self-fund easily because it's going to pay for itself with preservations.
Mhm.
And so we'd really like to hit that target where more and more people are doing preservation every year. And I guess it remains to be seen whether or not we can accomplish that.
Yeah. So how are you going to do that? Well, do you have brilliant new ideas? Because people come into this field every so often and they say, I can greatly multiply the growth rate here. Right? We had a certain Alcor CEO took over after I left and was basically saying, we're going to multiply memberships by like hundredfold or something like that. And it didn't happen, of course. It's really tough to get this to grow. So what do you base your
Well,
optimism about scaling on? How you got actually going to achieve this? Do you have a new approach?
well, what did he try? I'm so curious.
Oh, well, a bunch of different things, changing the pricing model and this and that, but I'm not sure
Uh-huh.
what was behind that that optimism. I
Yeah.
mean, even to double the growth rate, is actually quite hard to scale it up by two orders of magnitude. It seemed pretty implausible as it was. But
Uh-huh.
so I don't know. So, did you have a new approach that you think will really bring more people in?
I think that there's a lot of potential just simply in the protocol. This is something that gets a very high quality. And you can actually have neuroscientists look at the results of the protocol and be like, yeah, that probably does preserve memory. And even the ones who are skeptical on maybe religious grounds or some other sort of, grounds, it's not like a technical thing for them. It's more like, I'm not sure if I'm willing to sign on to something this unusual, right? Or they're not necessarily willing to put their name on the idea. But the science of it seems to be pretty sound in terms of what we can show. And that's never really been true before of the prior techniques. So we may also be in a bit of a different world now as well with the recent advancements in AI and other sorts of things. It does seem like people are more interested in the topic in general. So I don't know if it's a thing where I'm arguing that somehow we are exceptional, but I do believe that we have better quality and it's demonstrably better quality at now a threshold level where scientists sign on. And I think people in general are more receptive to this idea in the world. And so it seems like we're at a sort of inflection point where it's going to start working, even though it has never worked in the past.
Well, I hope that's right. We'll see. Yeah, I do wonder how much difference it makes. That neuroscientists say this might actually work. I think for some people that makes a difference, but I think for the vast majority of people, I'm not sure it will. It's because we've had various kinds of evidence before, and it doesn't seem to be a major factor for most people. I find in my discussions with people, people's objections are usually more either religious or psychological or fear of the future, or what am I going to do when I come back, kind of thing. It's not so much that they have technical objections. That actually seems to be a fairly small minority. But maybe if it's a fraction of the population, it might still be millions of people. Hopefully, if we can get the message across. But we'll see. I don't know. It's really hard to predict these things. I really would have thought this would have taken off a lot sooner, but
Yeah.
as you say, maybe the times are changing. Maybe with AI and even getting back into space, I think is kind of a sign of some optimism here. Uh,
Right.
a lot of people.
One thing I think that it makes a really big difference here actually is that whole body protocol. So you're asking me like, well, why does this make sense? Isn't it going to be more expensive? But if I go around and talk to people out there in the world who've never heard of this before, and I tell them the protocol involves cutting off the head of their loved one, they just immediately they're no longer interested. They're going to walk away. That's just utterly unacceptable. You mean you want to cut off their head? Why would you do that? Right? So just on a psychological level, a whole body protocol has real potential to take off where the head only version absolutely could not. Even offering the head only version, I think, has the risk of basically creating that strong association there. I think there are lots of little ways in which the community historically has failed to sort of reach the public where they are. This is a big one, but I think there are many of these.
Yeah, that's it's hard to evaluate that kind of thing because I mean you could compare Alcor and Crownix Institute. CI has never officially offered what used to be called neuro, I think incorrectly, but head-only preservation. But they haven't really grown faster than Alcor, so you would think that if that was a major factor, that they would have. And of course, now there's the brain-only option, which some people argue, and I think plausibly that's a different feel than brain than head. So I think we call it
Potentially.
cephalic, I think, rather than neuro. So there's something psychological different about removing the brain than chopping off a head. So, but how much difference that makes, I don't know. It's easy to make these sort of plausibility arguments, but it's actually hard to know. And then, looking at history, how much difference does that actually make? But I don't know. Um, And the cost issue also, of course, is a limiting one too, because if you're doing whole body, it is going to cost quite a lot. You say $250,000 is not small change for most people. Um, but on the issue of the business model, and you mentioned your venture-backed for-profit organization. Have you considered at some point, because of the uncertainty of the long-term stability, would you consider at some point maybe having a non-profit offshoot for handling the storage? So you've got the organization but doing the procedure, but then once you've got the storage done, that seems to be better suited to maybe a non-profit long-term structure. What are your thoughts on that?
Yeah, that's in our plan, down the road from where we are, because it takes time to set these things up, and we're a relatively small organization right now. But it's a fairly tried and true method. So, we're planning to learn from the things that have been developed over the years. The Alcor model has some significant advantages in certain ways for this sort of robustness and stability. Uh, so we're gonna use the aspects of that are reasonable for us,
Mm-hmm.
and I think a nonprofit for the long term storage is a pretty good idea.
And a trust like the Alcor,
Hmm.
the Patient Care Trust, or which also tomorrow Biostasis now has one as well.
Yeah.
Which to their credit, they set up within a few years of starting. It took Alcor quite a few years, and CI still doesn't have one. So it's really
Uh-huh.
just two, because I think that really does provide a lot of security for patients, knowing that the complete
Yeah.
funding is there for indefinite preservation.
Well, if you don't do the trust and sort of investment model, you really can't do long term storage of anything, right? Like you actually need that fund to grow over time so you can do a drawdown and have it be somewhat perpetual.
Well, I mean, you could, as CI seems to be relying on, you could hope for a continuing income over the years that's going to pay the expenses, but that is risky because if things don't, if you
Yeah.
stagnate or go into reverse or something bad happens or there's a scandal or whatever and things stop growing, then you're in big trouble. So it may not
Right.
be in principle necessary, but I think in practice it's definitely a good idea.
Hmm.
Yeah. So I understand that recently you have been writing with Ashwin Dubulf a article on biostasis pluralism, which I haven't seen yet. So I'd be curious if you could tell us a little bit about that and
Yeah, sure.
whether that's to be published.
Yeah, so that actually has come out now. It's on Ashwin's blog. Go ahead and check it out if you have a spare minute. But the thing I kept noticing when I was talking to people kind of in the cryonics space is there's this sort of bait and switch thing that happens in conversation with them where they are talking about a future protocol that will eventually be developed that will be reversible, as though the thing that's currently happening is reversible. And that is a significant error. Like there's a logical leap there that most people are making and they shouldn't be. And so if you look at just simply what does exist right now, it's not reversible, not in any sense. Um, and it will require significant repair. What this means, the implication of this, and this is something that until I started talking about it, it seemed like nobody was talking about it. But what this means is that if you have to repair those tissues in the first place, you need advanced nanotechnology. And if you have advanced nanotechnology, then you can use that same technology to repair chemopreserved people. And therefore, the context is the same. They are both biologically revivable if either is biologically revivable. And they are also both uploadable if either is uploadable for the same reason, assuming, of course, that the quality is there, that you can, in fact, trace the structures of the brain and really get the person back information theoretically. And of course, this is an open question, and there's some argument for there being a lot of redundancy in the brain, but it's the position of Nectome that if you have large regions of the brain that have been damaged, say by ice or by perfusion failure generally, then it will be the case that those regions are lost. And anything that you do to repair those regions will be essentially a like best guess of what could have been there given what hypothetically usually is there for most humans on average. And that's very different from getting the person back themselves. Even a person who was biologically revived but had significant portions of the brain repaired, that's not necessarily the same person. And so I wanted to kind of discuss this general state of things and hopefully, I guess, bring us all kind of together into a more unified family of technologies trying to solve the same problem. Because it really felt for a while like there was the chemopreservation people over here are doing this uploading thing, and the cryopreservation people over here are doing this revival thing. And ultimately, it's multiple different protocols, even amongst the same technique. You know, if you're chemopreservation, there's not just one type of chemopreservation.
Right.
And then if you are cryopreservation, there's not just one type of revival, right? Like these things are actually part of one sort of collective group.
Mm-hmm.
And in many ways, the current class of technology all has the same quality standards that should be measured.
It sounds to me like you would be taking a different position than, say, Ralph Merkel, who argues, on the basis of cryptographic techniques and so on, that you can actually do tremendous repair. I mean, there can be tremendous damage, and yet you can still potentially recover the person. So even people who are straight frozen don't have any protection. In your view, it sounds like you're not interested in doing that. You don't seem to think they have much of a chance, whereas others think that actually, even considerable damage is potentially repairable if there's sufficient traces left. So I guess that's something that I guess only further evidence can resolve that. It's kind of hard to do in principle until we actually do repair and see what comes back and compare it to what we had before. But is that a fair characterization, that you really don't have much optimism for people who've got straight frozen or significant, say, perfusion impairment?
Well, so it's hard to know for sure with these things, right? But if you look at what's there and try to interpret it, it's a lot harder if they've been straight frozen. If you want to trace the connectome and see what neurons connected to what neurons, it's often impossible. Like maybe you could do some amount of individual protein analysis or barcoding or something and kind of rederive what was originally there. But that's a much harder project. I expect it to take a lot longer and require even more advanced technology than a revival would take if you had the whole connectome in the first place. And there will be some error, there will be some loss, because every time you're trying to reconstruct a thing that's been destroyed, you're going to have decision points where you have to make an educated guess. I don't think it is the case that you will get a perfect, complete map of a whole brain by using methods that are repairing regions of the brain that were destroyed by ice. Now, whether or not that's sufficient to revive the individual, that's a question for the future. And maybe a question for individuals who are thinking about what to do. But in terms of the science we have now, most neuroscientists, I would say, are going to look at that and say, this brain is destroyed. I can't imagine any way this could be recovered. There's going to be some people who say, I can think of a way it might be recoverable, maybe. But in terms of if you're selecting from the possible preservation protocols that you might choose, if you're going to offer a protocol and you want it to work, it's going to be better if it's more comprehensive. It's going to be better if you can see all the synapses.
Oh, sure.
The closer you can get to that standard, the better off you are, just
Yeah.
in general.
I don't think anybody disagrees with that. It's
Right.
just a question really of is there a point doing it in less than perfect conditions?
Well, okay, so given that same argument, then you could say, well, straight freezing is pretty destructive. If you look at what happens when you add cryoprotectant, it's less destructive. And you can rule straight freezing out, right? You would rather have cryoprotectant than straight freezing.
Yeah, but you can't always do the cryoprotection. So then you have the question, do you go ahead anyway?
And I think that's a personal choice, ultimately.
Yeah. I don't actually, you say that you can't trace connections, neural connections in straight frozen brains. I don't actually know of evidence on that. I don't know anybody, has that actually been done very much? I'm not really aware of publications on that. That would be an interesting research project, actually. We've got the abstract discussions like Ralph Merkel's, cryptographic analysis, but actual studies of that, I'm not really aware of them. So maybe that's something we should be doing more.
Well, when I talk to, like, Ken Hayworth is a connectomicist, right? And so tracing neural connections is what he does. And if you show him some brains that are, preserved in different ways, or, preserved at different time frames, like say you take a biopsy from one of the pigs we did that was too long and a region of the brain didn't perfuse very well. And when it finally did, it was later or whatever, and you send that to him, there's a good chance he's going to take the slices and, there's you get like a stack of images and you try to build a three-dimensional map of some region of the brain. It's a very small section of the brain generally, but a few neurons maybe. You try to build that stack, there's a good chance it's not going to be possible. But if you take a brain that was perfused well during a short enough time window, and you look at it, it's like really obviously traceable. And so even in that case where it's like you just waited a little bit longer, sometimes it can be so significantly destroyed that it's untraceable from the standard connectomesis perspective. Um, and this is really the thing that is like the dividing line, I guess, for Nectome is if a modern connectomicist can look at this and trace it, it's at least meeting the baseline requirements for probably good enough. And if they can't, it probably isn't good enough.
Oh, yeah, so that's where the disagreement will lie, I guess, because I think Ralph actually sounded kind of annoyed at this, the idea of the connectome tracing as if that was the only way of measuring it. But yeah, I don't think nobody disagrees that the better you can do, the more you can perfuse, the more if you can actually trace the
Right.
connections. That's definitely the way to go. It's I guess it comes down to a question of what you think is reasonable to offer. So, for instance, Ken
Mhm.
Hayworth and Jordan Sparks have both claimed that what cryonics organizations are doing is unethical. Um, and I completely disagree with them. I think it's totally wrong, and I think that's actually a pretty lousy thing to say. We're trying to save lives here, but it's a matter of disagreement about what the possibility of recovery is, how much damage you can undergo, plus the fact that, of course, people who sign up for standard cryonics typically say, well, do the best you can. We don't really know where to draw the line, so let's give it a chance anyway. And that would certainly be my preference. I don't want someone to say, well, we haven't perfectly preserved your brain max, so we're going to destroy you. I'd rather not do that. I'd rather take my chances and see if I can partially survive. So, I think there are unresolved issues regarding that as to what's reasonable to try and what isn't. Um, I know Brian Wilkes talked about different types of cryonics. Basically, the science-based cryonics where you really try to optimize the quality, and that's something that you can say is plausible to work. And then there's the kind of the last ditch kind of cryonics where you don't really have much scientific basis for it, but it's kind of possibly might work. Nobody can be absolutely sure that it won't work. Unless you're actually completely destroyed. So I think this is why it's actually a good thing that we do have more organizations offering different protocols and different
Mhm.
options. If it was just Nectome just offering this, and most people are going to be out of luck, right? Because they won't be able to get themselves there. They won't be under perfect conditions. But the more organizations we have offering different options, I think the better. It's probably unless you can really demonstrate that it's not workable, it's probably best not to say that people are being unethical when they're actually devoted their lives to try to save people. That's just my view on that.
I'm perfectly happy having other organizations out there handling emergency cases the way that the best way that we can. It is commonly the case in different medical domains where you kind of screen people in and out of procedures based on whether or not they're likely to have success in that procedure, and based on whether or not the resources like make sense for the chance of success there. And
Mm-hmm.
so it might be something where in an eventual future, probably there should be a clear standard of this does this and does not do that level of preservation. This can achieve this marker, or it can't, or it has this percentage of coverage, or whatever like that. That should be applicable to every possible procedure, and then people can make reasonable decisions, or practitioners can make reasonable decisions about which of these is appropriate for which person and under which circumstances. I'd really like to see the industry as a whole kind of come together around how do we measure this stuff, because a lot of these conversations feel a little bit like, well, I think this is fine, and somebody saying, well, I think this is fine, but that isn't, and then there's nothing else you can say really because we're not comparing any numbers or looking
Mm-hmm.
directly at figures.
Yeah, no, I agree. It's very important that I know other people have written about the lack of feedback problem that
Mhm.
at least as it's been until recently, until we started doing CT scans and some occasional biopsies, which is still pretty uncommon. There's a real lack of feedback as to how well this is actually working. And you're asking people to spend a
Right.
lot of money on this, and but yeah, that's been a problem. I think we're starting to move in that direction right now with at Alcor. When I was at Alcor, we did start doing the CT scanning project, and that produced a lot of results. And now tomorrow Biostasis does CT scans of all its patients. Alcor did very few biopsies, mostly because it seemed to be hard to get the board to do this. They wanted everybody to give their permission and so on. It's just a hassle. Tomorrow Biostasis seems to be pushing that more aggressively now, is getting permission from members to do biopsies, which does give you some kind of feedback. Of course, there are things like the SMIC score that Ashwin and Mike Perry and others worked on. I think Steve Harris also early on. giving you some kind of objective measure of ischemic damage. These are all good things, and I think I'm very much in agreement that some kind of standardization, standard measures is a very good thing. That again doesn't necessarily mean that you're going to say you shouldn't do this because you're below that standard, but it makes clear to people what the standard is, and then they can make better decisions and more informed consent.
My take on this is that right now people don't want to have the standard because they're afraid that they will be excluded from their preferred method because of the standard. And I think that there will be discussions about whether or not one should or shouldn't do a given protocol based on the results of it, how it compares to other protocols. But I think that it doesn't make sense to avoid having standards so that you can continue operating in the dark, right?
Yeah,
We should go towards having a better understanding of how these things compare and how good are they, and then try to make better ones over time.
yeah, no, I agree. I think part of the concern is that there's been discussion for years about regulation, either government coming in and regulating the industry or self-regulation. And yeah, that is a real concern. I'm not personally a big fan of centralized regulation. I am a fan of certification, though. So if you have objective standards of the kinds we're talking about, you could have maybe a certification body. That doesn't mean that an organization can't run if it's not certified. But it just is basically telling people it doesn't have this level of quality, so you're kind of on your
Mhm.
own. And I sort of favor that. So rather than saying we have a standard, minimum standard that some group has decided, and if you're below that, you're going to go out of business. Rather than that, it's basically saying, you know, people have the information, they can decide what the quality is, they can decide whether it fits their preference. So that would be my preference on these objective measures you're talking about with certification rather than sort of an absolute barrier.
So
Um,
we're currently working on this, actually. What we're trying to do is get the Brain Preservation Foundation to establish certifications for preservation protocols. Right now, they're only really working with us, but I think that everyone should work together on this. And we should create a certification organization that certifies different types of protocols in emergency and non emergency contexts using whatever they're using in a way that has kind of an apples to apples comparison of what's going on and also does it or does it not meet this established standard.
well, that's something Biostasis Technologies would be very keen on working with them on. I think because it's that's
Yeah.
part of what we see as our role. Since we're not a provider of services ourselves,
Mhm.
we're interested in the research and in the standards. So I guess what we might end up with is something like I don't know if you're familiar with Consumer Labs. I think it's called Consumer Labs. Basically, it's a sort of certification agency that looks at supplements and various medical treatments and evaluates them and publishes the information in considerable detail to people who pay them for it. That would be a pretty good thing to have. So
Yeah.
um,
Yeah.
yeah, it'd be a kind of voluntary certification. Yeah.
So I think Ken and Ariel would love to talk to pretty much anyone who's involved in cryonics research or running a cryonics company or any of that sort of thing about different sort of certification standards and how this whole thing could evolve.
Okay. Yeah, we should follow up on that. Well, I've reached the end of my questions. I think. Is there
Yeah.
anything you want to say about Nectome and its future and or the industry in
Hmm.
general?
You know, it really feels like this is having a moment. This biostasis thing. I think that we as a group are and should continue to come together as sort of a singular industry and try and reach people more broadly in a way that we're not currently doing. Because a lot of the time people are talking to each other inside of the community, sort of
Mhm.
an echo chamber. And I think that it's time that we kind of go out into the world and actually reach the public at a, you know, more broad sort of area.
Yeah. Yeah, I think there's plenty of room for uh, people to speak about these ideas, persuade people, not on behalf of any one organization. I mean, I kind of in that role now because I'm no longer work for Alco. I can kind of be
Mhm.
independent. I can criticize Alco when I like, but I think that can benefit everybody if you have some good communicators out there pushing the ideas. It'd be nice if we had some good documentaries, for instance, which we keep happening sort of partially. We see some of that. It'd be good if there were some good movies. I know there's sort of Mortalist movies coming out. Um, yeah, I think any way we can improve standards, convey those standards, convey the
Mhm.
evidence to people in a compelling way, I think that will benefit all of us. Well, I wish you luck with Nectome. I thought everybody hopefully will flourish. All these different organizations will try their different efforts. We see which ones work best and which fit. So I guess, one final question would be, because since you mentioned the funding, how long are you good for at this point with the funding you have right now? Assuming you don't raise further funds, how long would you keep going?
I don't know if I want to get into the funding model of Nectome, honestly. It is inherently, startups are somewhat risky relative to other things, right? And we rely on a certain amount of growth to function, but I think we're going to get that growth. And additionally, we can get venture funding, and this has worked very well for us. We've been in research mode for a long time, purely on that basis, and I expect it to continue.
It's interesting because I think until quite recently, like the last few years, venture funding would not have been possible for something like this. I mean, there's a reason why cryonics organizations have been non-profits mostly, because they couldn't get people to invest. It's not something that was only investable. And I was
Right.
quite impressed that Emil managed to get pretty good funding for Tomorrow Biostasis apparently, and that you guys are getting funding. And then what's the other one? It keeps changing its name. It was Cradle Health or something, and you
Uh-huh.
know what I'm talking about. Also has
Yeah,
venture
yeah.
funding. Yeah, so
Yeah,
that's
I think it's
quite a new
until
development.
now.
Yeah, that's a pretty new development. So
Hmm.
I guess that is a good promising sign.
Yeah.
Yeah. Plus, these surveys that like Andy McKenzie and others have been doing these surveys of neuroscientists, showing that a surprising percentage of them think that this could potentially work. So these are all
So
pretty
this,
good
okay,
signs.
this is, I think, where the biggest leverage is. If we can get the scientific community looking at evidence and coming together on saying, yes, this works. This works if this threshold is met, this is good enough, or, serious debate about what part of it isn't good enough. That would be a huge improvement over the status quo,
Mhm.
because right now it feels like people are still very nervous to talk about the topic unless it's a private conversation. And in a private conversation, they're going to be perfectly happy, or if it's anonymous, they're perfectly happy to sign on to these ideas being plausible, reasonable, well supported by evidence. And they're just simply afraid to be the only one
Mhm.
speaking out in their field about it. And I think there are enough people in enough fields here that are related seeing the legitimacy of this kind of thing, that if they just simply had a way to know that so many others of them exist, it could become mainstream very quickly.
Mhm. Yeah, nobody wants to be the only person saying something unusual, but if they know that other people are also committed to, conditionally also putting their name on things, I'm thinking back about 10 years or so. One of the first person actually had some courage here was Sebastian Young.
Hmm.
Wrote the book on the connectome, and he accepted my invitation to come out and speak at the alcohol conference. I think that was 10 years ago, maybe 2015. And that took some courage, and he discussed it in his book quite reasonably. He didn't feel the need to sort of deride it or attack it like that. He actually discussed it reasonably, and now more and more people are willing to do that. One of the projects that Asher and I want to get to work on at some point this year is an expanded version of the letter from scientists, which used to be on cryonics,
Uh-huh.
but now be on biostasis, and that had several dozen pretty impressive names. If we can get to like 1,000 names, I think that will be quite impressive. So it's a project I think all the
Yep.
organizations can work on.
Yeah, there's a lot of potential in things like that.
Yeah. All right. Well, thank you, Jessica, for coming on. I know things are still kind of early days over at Nectome, so I wish you the best, and perhaps have you back on sometime in the future and see how things are going, and follow up on the evidence and on these standards. I think this is something really important that we can work together on, both the standards and on the getting the word out there. So thank you for coming on.
Yeah, thank you for having me. If anybody wants to send out questions or is curious, go ahead and send us an email, hello@Nectome. Love to talk to you.
And I'll put your contact info on the description for the
Okay,
podcast too.
thank you.
Okay. Thank you.